Hello and welcome back, my dear friends. So today we are going to discuss about the object-oriented concepts in C++. Okay, so there are basically 8 concepts overall related to the object-oriented programming in C++ or in any other language. So all those 8 concepts with respect to C++ language we are going to discuss today. Okay, so the very first concept that we will discuss related to the object-oriented programming, as you know, would be the class. Okay, as we have already discussed that class is just a blueprint for a real object. Okay, what does this mean? You might have seen some forms, like if you go to the bank or if you go to the go for admission in any college, then you might have seen a form where you need to fill some details like your name, your address, your date of birth, right? So if you see that form, you can only see some empty columns: name, father's name, your age, your date of birth, all those things you need to fill in. So this is a blueprint, or you can say a pro forma for collecting your information, right? So this is in the case of C++ language or in any programming language. When we create class, we do the same thing. We create a blueprint for collecting the information so that we can create a real object. So this blueprint, which identifies the kind of information, the kind of attributes that we need to collect, and the kind of, along with this, a kind of operations. Here in the form, we are only collecting the information related to the student or related to the any customer of a bank, right? So that blueprint only contains the information related to the customer or the student. But in case of C++ or in any programming language, when we write the class, along with the information or the attributes or the information that you need for a particular object, for a particular client, or for a particular student, these are just the examples. Along with that, in case of class, we also add the functionality, the functions as well. Whatever operations will be performed on the class object, those things are also included in your class. Okay, so when we write a class in a programming language, that contains the attributes which are known as the members, data members, and the methods, or you can say the functions. Okay, so when we write some class, when we declare some class, or when we create a blueprint for the objects in C++ or any other language which is known as the class, that contains not only the attributes but also the methods. Okay, so this blueprint is just like the blueprint or the proforma you get while you go to the college to get admission, or while you go to the bank to fetch your money. Some information is collected by the cashier. So all those things where some proforma is presented to you, some blueprint is presented to you, same thing is the class in C++ or in any programming language. So class is just a blueprint for collecting or for representing the information related to an object, a real world object, along with the functionality that it supports. Okay, that is the additional thing. Okay, in case of normal form that you see when you go to the college for admission, it not only contains the information which you will provide, it only contains the information that you will provide. But in case of programming language, it collects your information, like the attributes, like what is your name and other things, along with the functionality that it supports. Okay, like calculating the marks. Okay, all those things. If we are talking about a student object, so in that case, it will also contain the functionality that it supports. Okay, so that is all about the classes, the basic information about the classes. When we will see the implementation related to the classes, we will see more things. Okay, you will be able to understand it in more details as soon as we go ahead with the course. Okay, and we will do the practical implementation. Now come to the object. What is an object? This is the second concept. This is the second concept in object oriented programming language. Object is basically a creation from class. Okay, based on the template or the blueprint. When you create a new object, when you provide the information, you create a new object, then this is known as an object. Okay, creation from class template or from the blueprint of the class, creating a real world object is known as the object creation. Okay, creating a real world entity, this is basically a real world entity that can be physical, like a student, or conceptual, like what? Company. Okay, so any real world entity, when we create it from the related class, or you can say from the related blueprint, then this is known as an object. When we create a real world entity, then it is known as object. This real world entity, which is known as object, is basically non-differentiable from the other object. Objects are those which are non-differentiable from the other entity. Okay, non-differentiable. Let me explain you in more detail. What is the meaning of non-differentiable? Suppose you are creating a class car. In car, you fit the carburetor. Okay, you fit the steering wheel, you fit the engine. Okay, suppose you have created a template, or you can say a blueprint for a particular model of car. Okay, so when you will create a car in the factory, okay, in that car you will fit all those things: carburetor, engine, okay, petrol tank, everything you will fit. And every object, like if you have created 1,000 cars, what are 1,000 cars? These are the real world entities. And what kind of real world entities? These are the physical entities. So if you are creating a real world entity, and number of entities you are creating of the same type from a blueprint, okay, you have a blueprint for a car. It will have the engine, it will have the petrol tank, it will have the music system as well installed along with, it will have only 5 gears, or it will have the 6 gears, whatever. Based on the template, you are going to create the number of cars. There are some cars where only 5 gears are there, but there are few cars where 6 gears are there. Okay, so in that case, what will happen? You are creating number of cars which cannot be differentiated. Number of cars, you can say number of entities for a particular blueprint which cannot be differentiated from each other. So whenever there is a situation that one object or one entity cannot be differentiated from the other entity, then this particular entity is known as the object. Non-differentiable entities, okay, non-differentiable entities created from a class are called objects. Okay, so objects are always non-differentiable. Object is just the creation based on the template. But again, take the example of car. You have created number of cars. Now these cars are in the market. Now every car has a number plate, every car has a RC. Okay, every car has a registration number. Okay, that number that you see on your car, that is the registration number. So if every car has a registration number, that registration number is what? It's unique. No two cars could have the same registration number. Okay, so if these two cars don't, if there are number of cars created out of a particular blueprint, and each of these cars have a separate RC, or you can say a separate number plate, using which they can be identified separately. All these entities can be identified separately. Then in that case, they are not known as objects, they are known as instances. Okay, so instance and object, they are very closely related. Okay, but the only difference is that the instances are uniquely identifiable, but objects are the creation. They can be number of creations. You can, based on the car template, you can create 1,000 cars, and every car has the same thing. You cannot differentiate from one car to the other car, like how to identify this car from this car. How I can differentiate from this car to this car, because this is only based on the template this has been created, right? but when it comes to the market, then that car will have an owner, right? So to make a particular person owner of a car, the owner of the car, you need to identify that car with a specific number so that it can be differentiated from the other cars of the same model, right? Of the same type, because all the cars from outside, they will look similar. Okay, so if they look similar, in that case, to identify them separately, you need to provide a particular RC, a particular registration number. Okay, you need to have a registration certificate. Based on that, you will get in the registration certificate, you will have the vehicle number. Okay, so that vehicle number uniquely identifies your object. So when the objects are uniquely identified, then those objects are known as the instances. So now I hope you might have understood about the difference between the instances and the objects. These concepts related to the objects and instances, they are most of the time they are confused. Most of the people are confused related to the concepts of the objects and instances. But now I think you might have understood what is the difference between an object and an instance. Okay, so two concepts related to the object oriented programming. First was the class, second was the object, and additionally we discussed about the instance. So these two concepts we have discussed. Now third concept is the encapsulation. Okay, encapsulation, what is the meaning of encapsulation? So let us understand with the help of an example. Suppose there is a company. Okay, a company is there. In a company, there is a sales department. Okay, and there is a finance department. Okay, finance department deals with all the finances of the company. Okay, whatever comes in, whatever goes out, whatever company purchases, whatever there is inventory, everything finance department is taking care of. Okay, whatever finance department is taking care of, that has some data. Everything is data. Whenever you are dealing with something, you need to collect all the information. So to collect the information, you need to organize the data. So to organize the data, you must have some data, right? So every department collects the data. So that data related to the finance department is with finance department only. Okay, and there is a sales department. Sales department also has the data. Okay, because sales department is dealing with all the sales, whatever has been done by the company. Okay, so all that sales data is with the sales department. The sales department has a set of data, finance department has a set of data, but this finance department cannot see the data which is with sales department, and this sales department cannot see the data which is with finance department. Okay, so if sales department want to see the data related to the finance department, or vice versa, if finance department want to see the data which is with the sales department, then in that case, what they need to do, they need to ask for permission. They need to meet someone from the sales department. Suppose finance department needs some data from the sales department, then there must be some representative from the sales department to whom this finance department representative need to connect. Okay, so if this finance department need to connect to the sales department, then in that case you can understand that by default or naturally the data for the finance department is hidden by the sales department, and whatever data is with the finance department, that has been hidden for the sales department. So this kind of data hiding, is known as what it is known as? It is known as encapsulation. Okay, encapsulation is nothing but hiding the data. The simple definition is hiding the data. I hope you might have understood what is the meaning of this. Okay, hiding the data. And how you hide the data programmatically? You create a class, and inside the class you put all the members of the class. What are the members of the class? Suppose you are creating a class student. So what will be the members of the class? The name of the student, the date of birth of the student, all these things, all the attributes related to the student, they will be the members. They will be called as the members. Then there will be the methods. Okay, those methods will work on the members, data members. Whenever there are methods, suppose you have created a class which will add two numbers. Suppose we have created a class named mathematics. Okay, in mathematics you have created that class, and in that class you have two members, two operands will be there, number one and number two, and you are going to perform number of operations like addition, subtraction, and everything, right? So all that member like number one and number two, and all those methods like addition, subtraction, multiplication, all those things you have written inside the class itself. So when all the things are within the class itself, okay, and all the things are done within the class itself, you create the object of this class, and all the things you can only perform through inside the class itself. There are some methods, and those methods are only performing the operation on these members. Then this kind of arrangement is known as the encapsulation. So you create the class, you put all the members and the methods who will work on those members inside the same class. Then in that case it is known as the encapsulation. Okay, so as we discussed that we have the representative. If you have to get the information, if a finance department person need to get the information to the sales from the sales department, then in that case there must be some representative, okay, to whom you will ask. Okay, so in that case, if you have written a class, when you will create the object, then how that object will give you the information? There must be only one function, there must be some function or the some set of functions you can use to get the information related to the members, related to the operations. Okay, but all the members of this class cannot be available to you inside your program. Okay, so all the members inside the class, when they are hidden, all the attributes when they are hidden, how they are, how they look like, what is the actual data, that you cannot see, you cannot access, right? For that there are access specifiers to maintain, like who can access what. For that, access specifiers has been maintained by the languages. Okay, for C language we have private, we have protected, okay, we have public. All these kind of access specifiers are there, which we will understand in the coming videos, in the coming lectures. But as of now, just understand that data hiding is the main objective of encapsulation implementation. If you are going to implement encapsulation, then it means that you want to hide the data that this particular class maintains from the outside world. In that case, you will implement the concept of encapsulation, and in any condition you will not be you are not going to expose the member variables of that class to the outside world. Anyone who wants to get the information, he can get the information through a method of that class. Okay, if you create an object of the class, using the object of the class you can access the methods. What methods? The public methods. Okay, we will understand the meaning of private, protected, and public, but as of now just understand, just just take it as it is, whatever we are understanding. If you know, that is okay, but if you don't know, in the coming videos we will understand the meaning of public, private, and protected. What is the meaning of these access specifiers and why they are known as access specifiers? All those things we are going to understand. Okay, now after the encapsulation, the next concept is the abstraction. This is the fourth concept, abstraction. In case of encapsulation, we were hiding the data, we were hiding the attributes. But in case of abstraction, the objective is, what is the objective of abstraction? Not to hide data, but to hide implementation. Okay, you hide the implementation. Let us take a real world example. Suppose you have a car. Okay, in that car you have a steering wheel, you have accelerator, brake, clutch, all these things you have. Okay, when you push the accelerator, your car accelerates, it gains the speed. But what is happening behind the scene, how it gains the speed, that you don't know. And this is what the implementation is. Okay, when you press the accelerator, there is a mechanism, there is a engineering behind the scene. There is a functionality behind the scene which is actually accelerating the speed of your car. But how is it accelerating? What is the engineering behind? That has been hidden from you. That thing has been hidden from you. You just need to push the pedal and your car accelerates. So whenever we are hiding the implementation, then in that case we say that we are implementing the abstraction concept. Okay, so hiding the implementation is the abstraction and hiding the data is the encapsulation. So this is all about the abstraction. How we implement the abstraction in C++? Using the virtual functions. Using the virtual functions. Okay, abstract class pure virtual functions. What are they? That we will discuss in the coming videos. The virtual functions, pure virtual functions, they doesn't allow you to create the object. Okay, so that you can only specify what kind of access you need, what kind of object you need, and for what kind of object, what kind of access you need. So all those are implementations done using the abstraction concepts. Okay, so that implementation that you hide, then in that case we say that we are implementing the concept of abstraction in C++ or in any other language. So hiding the implementation is the abstraction and hiding the data is the encapsulation. Okay, now let us see the other concept, which is the fifth concept, and this is known as polymorphism. What is polymorphism? Polymorphism means one thing in many forms. Okay, suppose there is a person. Okay, that person can be a son, can be a father, that person can be a husband, that person can be a teacher. Okay, so a single person can take the form of a son, father, husband, teacher, any of the forms. He can play any of these roles at any particular point of time. When he is playing the role of son, he cannot play the role of father, husband, or teacher. When he is in the role of husband, he cannot play the role of father and son. Okay, for your wife, you are only husband. You are not her father or son or teacher, right? So if you are playing a role of a teacher, then you cannot be any other thing: son, father, husband, teacher. So when one thing exists in many forms, can exist in many forms, then that concept is known as polymorphism. Okay, so this concept is also implemented using in the C++ language using the virtual functions. Okay, what are the virtual functions? They enable you to implement the concept of polymorphism. How it helps you, that we will discuss when we will do the practical implementation. Okay, as of now in this video you just have to understand the concept. What is the meaning of abstraction? What is the meaning of encapsulation? Don't worry about these things. If you can't remember these virtual functions, if you think that these are the jargons for you as of now, just forget about them. When we will study about them in the coming videos, you will become comfortable with them. Okay, so the virtual function practically we'll see in the coming videos, but as of now, if you have to discuss about the polymorphism, if you have to understand about the polymorphism, then it has a very simple definition that when one thing exists in many forms, then it is known as polymorphism. Similarly, you can see like there is a vehicle. Okay, that vehicle can be a car, that vehicle can be a motorbike. Okay, that vehicle can be a truck. So all these are the type of vehicles. Okay, so these are the different forms of a vehicle. A vehicle is a car is a vehicle, a motorbike is a vehicle. So a vehicle can be considered in many forms, in the form of a car, a four-wheeler, in the form of a two-wheeler, in the form of a truck which has more wheels, right? So a vehicle can take many forms, can be considered in many forms. Okay, so wherever you can consider one thing in many forms, there is the concept of polymorphism. How we will implement it, that we will see in the coming videos when we will move ahead with the concepts related to the C++ programming language. Okay, and now comes the next concept related to the object-oriented programming language, which is known as the inheritance. Okay, suppose you have created a class vehicle. Okay, you have a vehicle. That vehicle has few things. Okay, like basic things are there. Okay, suppose let us take a real world example. Suppose you go to a shop. You go to a shop where you can find out the pizza base of pizza. Okay, you can get the base of pizza. Suppose along with the base of pizza, he provides you some basic things like what you can say. He provides you the olive oil or olives. Okay, suppose he provides you the olives. Already the olives are there on the base of the pizza. Okay, now you get the base of the pizza, you get the olives, and suppose you get the tomatoes by default on the base. Suppose that a shop is selling the base of the pizza with olives and tomatoes, sun-dried tomatoes, whatever. These two things you always get on the base of your pizza. So this is the basic pizza that you have got. Now you are going to create number of pizzas. Okay, one flavor is like farm pizza. Second can be chicken pizza. Okay, third can be what you can say. Uh, uh, I cannot remember the name. I can imagine that thing, but I'm not able to guess the name. Yeah, it's cheese, cottage cheese. Okay, cottage cheese. So you have a cottage cheese pizza. You have other type 4. Suppose type 4. I'm writing it. So you have different type of pizzas. Okay. So for this kind of pizza, like farm pizza, you have a template. You have a blueprint. Like whenever you will create farm pizza, you will put on the base of pizza, which you will get like on the base of pizza, you are getting olives and tomatoes already you are getting. But on the farm pizza, on that topping, on the top of the base, you will put some new things like some spinach. You will put some other vegetables you are going to put. Okay, so you will have a template like what vegetables you will put. So that will be a separate format. In case of cottage cheese pizza, you will have a separate format. In case of a chicken pizza, you will have a separate blueprint, like this much chicken you will put, this much of oil you will put, this much of you will whatever you along with the chicken, whatever you are going to put, are you going to put the extra cheese, whatever you are going to put in the chicken pizza, that will have a separate blueprint. So whenever we talk about the blueprint, all those are the classes. So chicken pizza will have a separate class, separate blueprint. Farm pizza will have a separate blueprint. Cottage cheese pizza will have a separate blueprint. And type 4 pizza, the special pizza of your store. So in that case, what will happen, that all these kind of 4 kind of pizzas will have separate blueprints, and all those blueprints are inheriting the same base, which is the base of the pizza having olives and tomatoes. So when you use something which is already, when you use some properties, or when you use few things which are already there, and on top of that you add something specific to create a new object, then in that case this is known as the inheritance. So you are inheriting the farm pizza from the basic pizza. Okay, that basic pizza only had olives and tomatoes. That base of the pizza only has olives and tomatoes, and you are inheriting your farm pizza from the base of the pizza. Okay, so you are putting extra things on top of the base pizza to create a farm pizza, chicken pizza, cheese, cottage cheese pizza, and type 4 or a special pizza of your store. Okay, so basically what we are doing, we are inheriting from the base pizza. Inheriting from the base pizza, what we are inheriting? We are inheriting farm pizza. We are also inheriting chicken pizza. We are also inheriting cottage cheese pizza. We are also inheriting special pizza, SP. Okay, like that. So this is known as inheritance. Okay, this practice is known as inheritance, where you are inheriting few things from the base blueprint, which is common for all. In all the pizzas, olives and tomatoes will be common because you are using this base for the pizza. So when you put the cottage cheese, olives and tomatoes will always be there. So when some existing things are always there, and when some common things are always there in few of the objects, that few other type of the objects that you are going to create, then in that case we are implementing, or we are following the concept of inheritance. So inheritance means inheriting or acquiring or reusing. Basically, you can say, in appropriate words, you can say reusing attributes or functionality from some base class or object. Okay, from base object. Okay, an object always needs a class. So whenever you are creating a base object, then it means there should be a base class. Okay, so the class from which you will inherit, that is known as base class. Okay, subclass, the inherited class is known as the subclass. Okay, inherited class is known as the subclass, and the class superclass, the base class from which you are inheriting, that is known as the superclass. Okay, superclass is the class using which other classes will be inherited, or other objects will be inherited. So for those kind of objects, when you write the class, those classes are known as the inherited classes. So when you will write the classes, then if you will implement this pizza thing, then base pizza will be the superclass, and your farm pizza will be subclass. Okay, what else will be subclass? All the other cottage cheese pizza, that will also be subclass. Your special pizza, that will also be the subclass. Okay, and your chicken pizza, that will also be a subclass. How we do the subclassing, that we will see when we will practically implement the inheritance. But inheritance is a concept that is implemented in the C++ or in any programming language, because whenever we are solving the problem through our software, we are solving the real world problems. So all the concepts that are utilized in the real world, all those things we need to consider here. All those concepts are taken here. Okay, so this is called the inheritance. Now the seventh concept. What is the seventh concept related to your object-oriented programming? So that is dynamic binding. Okay, dynamic binding is like finding the function call at runtime. Okay, what does this mean? Suppose you have created a class with vehicle, with name vehicle. Okay, so when you create a class vehicle, you have a class vehicle. This is the superclass. Vehicle is the class, and using the class you have created a car, you have created a bike, you have inherited a bike, because from vehicle is a common thing. Like every vehicle has a vehicle number, right? So the few of the common things are like vehicle number, and number of tires. Okay, the engine number. All these three things, basic things, are always there in every vehicle, whether it's car, whether it's bike. Okay, so there are few base class attributes which are there with vehicle, but there are other classes which were inherited from the vehicle. Right now we have understood the concept of inheritance, so extending that, we are just going to discuss here. So you have a car, you have a bike. Okay, so you have inherited that, but your application is providing the functionality, like when the user is using your application, he can choose to create the object of a bike or a car at runtime. You don't know what is needed to the client at runtime. Okay, when you know that you don't need to specify what is needed to be called, what is needed to be chosen by the client, in that case you do the static binding. That static binding is done in C language, but in case of C++ language, with the help of virtual functions, with the help of inheritance, with the help of the polymorphism, we are going to provide runtime polymorphism, runtime binding, right? Suppose your customer wants to create an object of bike at runtime, then how can you decide it at the compile time? So when you are writing the code, you cannot decide. It is decided at the runtime. When your code will decide at runtime that what object need to be created, because of your client or because of your user going to decide that at runtime, in that case this is known as the dynamic binding. So when it will decide your object at the runtime, then also at the runtime that client is also going to use the functionality of your object, right? Suppose at runtime he creates the object of bike, he want to set the price for bike at the runtime, so there will be a function which will be setting the price of the bike, right? So all these functions and attributes and data members we will see when we will implement the things, but as of now you just make up your mind like how they you can just consider, you can just imagine how they work, how they could look like, right? So at the runtime your bike object will be created by your user, and that the price of that bike will be decided by your user only. You have written a software for your client, and that client is using, that the client is maintaining a number of vehicles, they are producing cars, they're producing bikes as well, and they are setting the price, market price as well, right? So all those things, suppose your client is going to create the object of the car, right, at runtime, or object of the bike at runtime. So in case of bike, there will be a range of price, like this is the range of price. So from that range of price only the price can be set, right? So in that case what will happen, that particular client will use the function related to the bike class which is setting the price for the bike. Similarly, if he creates the car object, then there will be a function in the car class which will be setting the price for your car, for your particular model of the car, right? So whenever there is a decision made at runtime, like what function will be called, then in that case the concept implemented is known as dynamic binding. Okay, so the dynamic binding is a concept where the function calls are decided at runtime based on the object created at runtime. Okay, that is the simple definition. So the very simplistic way you can say that finding the function call at runtime is known as the dynamic binding. Okay, making the function call at runtime is dynamic binding. Now let us come to the last concept, which is known as the message passing. Message passing. There is an object A and there is an object B. Okay, A has some information, B has some information. A and B, suppose A wants some information from B. We saw the example earlier, like there is a finance department, there is a sales department. So sales department wants some information from finance department. So in that case, finance department, suppose it's finance department and it's sales department. B is sales department, A is a finance department. So finance department needs some information from sales department. So in that case, it can pass a message to the to the sales department. Okay, and what message that can be? Message can be like, I need the total sale done by you in this particular quarter. Okay, sale done by you in particular quarter 2, say. Okay, so in that case what it need to know, this finance department object need to know, first thing, what object it need to call. Second thing, it need to know what message it need to send, because based on the message this sales department will give you the information back. There will be a function inside this class for the sales department which will be giving back the information based on the message, based on the request. Okay, second thing is the message, and third thing is what is the name of the function. Name of the function means what functionality you are expecting from the second object. So message is like I need this. At the same time, you need to pass the name of the function. You need to call the function because you ultimately have to call the function, and that function will contain the message that this is the message, this is the function. You will call the function, you will pass the message that I need some information, because this function which will accept the message from the other object is the representative, okay, of the sales department. This function, you have written a function. How to write the function, that we will see. As of now, you just imagine like how the things will be going on. You need to revisit this video again and again in future. Let me tell you, whenever we will implement something in the code, you need to revisit this particular video again and again. Okay, so this function will be accepting a message. Okay, so this function accepting the message will be returning the information based on the message. Okay, so this function has become the representative of sales department or the other class. So this is known as the message passing. When one object sends some message to find out some particular information related to that object, in that case it is known as the message passing from one object to the other object. This procedure is known as the message passing. Okay, so these are the overall 8 concepts related to the object oriented programming language. Okay, and that is all about the today's video, today's lecture. I hope you might have understood at least the basic information related to the concepts of object oriented programming. So you need to focus from today's video. If you are able to understand everything, then that is really good. But if you are not able to understand everything, then at least understand the definition, at least understand the real life connection of object, real life connection of class, real life connection of encapsulation, abstraction, polymorphism, inheritance, okay, dynamic binding and message passing. These 2 concepts are very much dependent on the programming understanding, dynamic binding and the message passing. But rest of the informations, rest of the objects, rest of the concepts like inheritance, your abstraction, your polymorphism, all those things are very much closely related to the real world incidents, real world scenarios. Okay, so at least understand these concepts with respect to the real world concepts, with respect to the real world scenarios. Okay, later on, whenever we will move ahead in the coming videos, we will see the implementation practically in code. Then in that case, you will be able to understand like how they are implemented, how they are useful, and how we can connect with the real scenarios, and how we can implement the requirements from the client, because the requirements from the client are always going to solve some real world problems. Okay, so that is why these object oriented concepts we must have to understand, and this particular lecture is very important. Okay, so whether you are a student of class 10th, 12th, or you are doing graduation, or you are doing your BTech or MCA, this particular course is for everyone. Okay, you will know by the end of this by the end of this course, you will become a programmer at the moderate level, who knows the programming, C++ programming language at a moderate level, who can implement the things independently using the C++ language, whatever will be asked to you. Okay, so with this, I'm just going to close this video, close this lecture for today, and in the next video you can move ahead and see my next lecture.